transformations to describe them, but if you want to, you certainly can. But what we see by that vertical stretch is this is going to be narrower. So that's why your intercepts are very important. Look where your y-intercept is, way, 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 way up there. It's very narrow with the 3. Yes?
Why is on the increasing and decreasing y?
Y is the 4. Wait, let me just move this thing. It's sitting right on my increasing, decreasing. Okay, so on the increasing, decreasing, you are decreasing from negative infinity till you hit this x value. Your y value is decreasing negative infinity to negative 4. Then you're increasing from negative 4 to infinity.
No, I get that part. I said why is it a hard bracket?
It's a soft bracket. It's a soft bracket because increasing, decreasing share, and technically by definition, if you are decreasing, all these numbers in here, all these x values have the y's that are decreasing. When it gets to this point, it neither decreases nor increases. So that's why they technically say no hard bracket. Increasing, decreasing always uses a soft bracket. And this is exactly what I'm looking for. If you give me axis of symmetry equal 4, it's wrong. It's an equation of a line, a vertical line. It has to say x is equal to 4. It has to go through this point, a vertical line. I want these algebraically. If these can be resolved at this point, I'm 1 plus or minus 1 minus 4, or negative 4 plus or minus 1. These have to be worked out. If they're radicals, then simplify them, leave them there. Amani? You don't have to, just give it to me. If it's a plus or minus radical 12, you have to simplify your radical. If it's 6 over 8, when you figure it out, you got to reduce your fractions. That is a given in pre-calc honors. We never say reduce. You have to. The only thing you don't have to do anymore is rationalize the denominator. But that's a given. And any answers that come out that you would have a calculator for, that is 3 decimals. You only won't get 3 decimals out of these because you don't have your calculators. And again, if you're checking this, put your original one in. Put your transformed one in. Y2. It has to be the same graph. Has to be. Questions at all on this? No? Did we do number 1 in class? No? Okay, let's do number 1 since I don't have it. Okay, number 1 says complete the square. Keep the x's by themselves. If you keep it to one side, you add, you subtract. If you put it to the other side, you add, you add. I don't care if you do that, just bring it back when you make your equation. So half of b is what? Half of negative 4. Good. Remember just to put your minus 2 squared. What is 2 squared? 4. This is your completed the square. And then put your plus 5. Here's my equation. So now, what do I know? What is my vertex?
2, 5.
2, 5. And where do your transformations go? Right 2, up 5. So doesn't that match your vertex? 2, 5. It all works together. Over 2, up 5, vertex. Which way is this opening, up or down? Up. So now, I need to kind of know where this is going to open. If I look at my y-intercept, I obviously don't have an x, but we'll figure that out in a second. If I put this into my original one, and I need to see this part, y is equal to 9. So if this here is at 5, y at 9 is somewhere up here, we're fine with this. Somewhere up there. Yes?
Is there in the original equation?
No, you can use this one. You can use either one you like, but then in this one, it's forcing you to just do some more math. In this one, it just blocks everything out. Whichever one you want to use is fine. This one, the vertex one, definitely x-intercepts. So when we do the x-intercept, plug it into that. If you plug it into this, then you're forced to either quadratic equation, complete the square. So since you already have that, plug it into this. Now, when you get to this point and you subtract 5 and you take the square root, well, we don't take the square root of negative numbers in our real number sense. So we say no real either roots or x-intercepts, whatever you want to call them, or zeros, no real zeros. They're imaginary, and we're not going to worry about the imaginaries. We're just going to say no real. Your axis of symmetry, again, is the x equals whatever this is, because it cuts through that x value. And increasing, decreasing. So the first thing through, I'm decreasing from negative infinity to what x value?
2.
And then from 2 to infinity, I'm increasing. Your test is going to look just like this, just like your homeworks. In fact, I cut and pasted it right off your homeworks. I might have changed one of the equations with 1 or 2 numbers, but basically there's not a lot to do. I mean, there's not a lot to change.
When we do the
Yes.
you square it because it has a square and then you use a zero like
I
that?
square rooted it to get rid of the square. To undo a square, you square root. So if it said this, don't you square root?
Yeah.
So,
Can you just like leave it like that?
well, yes, because we're only dealing with real numbers. This is a real XY graph. So we don't have imaginary roots on this, on our XY graph. These roots are imaginary because they don't touch the x-axis. But we would have to take the I out and work with a, when you work with a graph, it's this. It's x, y, I. That's where your imaginary comes from. We're not on an imaginary, we're only working real. So whenever you have square root of negative, just say no real x-intercepts. And doesn't your graph confirm it? Right? Now, if I was doing this, and I came down here, and this, for some odd reason, came back and it said y equals negative 9, and I'm looking at this and I say y equals negative 9, okay, I have 9, something must have went wrong, I'll just figure it out later. Work on this. Maybe you didn't, maybe you forgot to take the negative out. Maybe there was a negative in front of it and you forgot to take the negative out. These all should jive together. So if something doesn't, go back and look to see what went wrong. That's the nice part of this. You're graphing off of what you found out. Everything has to fit together. Your vertex is your transformations. So they all work together. That's what I like about this. You can see so much together on this. The reason why you do all these things. Okay. So 3. We have a leading coefficient of negative 2. Our leading coefficient always has to be a positive 1. So whatever that is, take out the negative 2. Factor out. Just out of the x's. Leave the constant term alone. If you factor it out of the x, and then you factor it out of the constant at the same time, that has to stay in parentheses. And inside the parentheses is where you have to complete the square. Then you have to distribute to get everything out of there. So just keep it separate. Leave this be out here. Just deal with your x's. It makes life a lot easier. If it helps you, do this. Negative 2, negative 2. Take the negative 2 out. This is going to change your sign. So now, this is where you want to complete your square, right here. Half of negative 6, negative 3. The nice part about this, we square a positive, we square a negative, we always get a positive. So that's why we always add. Yes?
Isn't negative 2 times isn't negative 2 times positive 9 negative 18?
Yes.
Oh, minus,
Yeah. Don't get confused with that minus sign. Put your minus sign down first. Whatever I add here, Alexia, I have to subtract here. So that's what this blue does. This blue says subtract it. This negative is because we had to get it out of that parentheses. We had to distribute it. And what happens over here, put this in your calculator if you have, well, you don't have a calculator on this. But when you subtract a negative, use the rule. Take the opposite and add. So it's negative 16 plus 18. You guys should know that. Vertex Here's my transformations. To the right, 3, up 2, 3, 2. There's my vertex. Has a negative out in front, it opens down. So case in point, say you forgot to say it opens down. You write opens up. When you do this y-intercept, you're going to be sitting down here. Your graph is going to be sitting up here. Something's wrong. Check it. Because sometimes we write that -2, but we're so used to looking right in here that we write the graph going up. Axis of symmetry, increasing, decreasing. These, when you do your zeros, when you get to this point right here, you have to resolve this. 3 minus 1, 3 plus 1. Those are my intercepts. 2, 0, 4, 0. If it's a radical, just reduce it and leave the plus or minus. And estimate where it's going. If it's a radical, you can estimate that. But it kind of gives me a hint on where that's going. The 2 gives me a little bit of a stretch to that, so it's a little bit narrower. The most important part is right here. I don't want to see your graph go like this. This is wrong, because this is where I'm the most concerned about. Do your intercepts before your sketch, and then don't do this to me. So if you have to, cross that out, but do your intercepts first, because I need to see where does it fall compared to that origin.
Do you want us to label the vertex on the map?
No, if you want to, but I need somewhere that says vertex. And I like to label it. It helps with the increasing, decreasing. It kind of just puts it in perspective, but whatever you like to do. Questions at all on this? No? Okay. This one we did in class, right? This one, be careful of the 1/2. You're going to take out a factor of 1/2. You're going to divide that out. And again, it doesn't cross the x-axis, so don't tell me no real zeros. Prove to me that there are no real zeros on that one. Okay, that one we did yesterday. And this last one, I know this last one was a little trickier. There's a couple of ways you can look at this. First case in point, you can do, First case in point, you can do this. That's your complete the square, isn't it? Right? So say you don't see that. Because the first time I looked at this too, I thought, oh, this is an easy homework problem. But then I thought, yeah, it's kind of like a little tricky. So another way you can do this is this. I have no middle term. So what is my middle term?
0x.
0x. So once you do this, you're going to factor out a 1/2. If you divide 0 by 1/2, what do you get? 0. And here's my -4. Am I adding or subtracting anything? No, 0. So I look like this anyway, right? So if you get confused, use your middle term or expand this. These look exactly the same, right? So either way, we're okay with that. So this hasn't moved off. Look at your transformations even. Work your transformations. This has a shift down. From where? If I just have a shift down, and don't worry about the shrink yet. If I just shift down, where's the shift down from? The origin, right, the x-axis. So if I shift down here, there's my vertex, 0, -4. So use your transformations. That's another good way to see that. And then I can say, oh, yep, that's my stretch. It's going to make it a little bit wider. God bless you. I know my vertex. I know my axis of symmetry. That's really all I had to know. Your transformations is why you put this into the vertex. You find you write in vertex form. You find your vertex. You can figure out everything from there. And here's a good one, too. This comes out to be the square root, if you can see it down there, back there. When you take the square root of these guys, you have to simplify this. So it's plus or minus 2 radical 2. And again, if you're looking to see where this goes, radical 8 is close to a perfect square at radical 9, right? So it's almost 3. So 3 to the left, 3 to the right. You can estimate that. That's what the shrink does. It stretches it out a little bit. Any questions at all? This is what your test is going to be on Monday. Exactly this sheet. Exactly. It will be carbon copy. I literally pasted it from it. Literally.
So, there's no other questions, it's gonna be just these?
Two of those types of questions.
It's two of these.
Two of those types of questions.
So it takes like what, 10 minutes?
I'll give you the period to do it, but it probably will take you maybe maximum half hour maximum. I mean, I know when people take a test, they like to go over it carefully and go over it again, and I think that you should. And you should step back and make sure that your intercepts look like where your graph is going.
But you're not allowed to use your calculator.
No calc.
So not
But really, did you need to pick up your calc on this at all?
I
I
need to check it.
honestly didn't even know how to multiply, like, by half. I didn't know. Like, I
Multiply
didn't know
what by
that-
half?
That, well, no, 4 divided by half is 8, but like, it makes sense. Like, right there, yeah.
Oh, okay. So when you do this, watch. This is called a complex fraction. Keep this, put it over 1 if it helps. So keep the first one, change the divide to a multiply, and flip the second one. All it is this. That's all it is. See, if you read the complex fraction, it looks like this. So your rule is keep, change, flip. Same rule. Yes.
Would it be right if you put radical 8 0 and negative radical 8 0?
No, because you have to reduce your radicals. I mean, it's not, you got the right answer, but you have to go one step. You'll lose a point for not reducing it. Yeah. In pre-calc, we are like exact. But in algebra, you start being that exact. You start following things until the very end of the lesson. In pre-calc, everything is a lot more exact. And when you get to calculus, by far. Yesterday, anybody know Chris Kirby? He's a senior. He came in my 7th period class to ask me for something. And so I had him talk about Reagan talk to you guys. So I had Chris, and he's like, huh, she wasn't kidding. 3 decimals. No, we go more than 3 decimals. It is so exact. So that was a good thing that he said. But so he said, everything you learn here, you will use in calculus. And he has Mr. Me. He has BC. So does Reagan. Do you guys have questions on this at all? Okay. Easy test grade on this.
Are we gonna have horizontal sketches?
I'm not gonna